Welcome to homework.
Question we are asked if the symmetric closure of reflexive closure of transitive closure of a relation necessarily an equivalent relation. So there are three steps here. We start with a relation. We made a transitive closure of it and use whatever we get to make reflexive closure, and then use the result to make symmetric closure again. So the order of closure that we use is important. So we have to do it step by step, transitive first, reflexive, then symmetric. And I would like to tell you right now that the answer is no. It's not necessarily an equivalent relation, but it's not it's not really easy to see why unless you see a counter example. So I will show one to you right now. It can have it probably has many other counter example, but this is one of them. So we start with, so the set X has 4 elements A, B, C, D, and relation R on X consists of 3 things: A, B, B, C, B, D. Okay, and that's fine. So first we made a transitive closure. Transitive closure here would be the smallest relation that contain R, and it is transitive. So it's gonna be R union with element that made this whole thing transitive, right? So we have A, B, B, C, so we would need AC in there. We also have BD, so we will need AD in there as well. And that's it. This is the smallest one because we add only the things we need to make it transitive, right? So this is transitive relation. We will call it RT. Okay. Next, we would make a reflexive closure of this RT we just obtained, and we will call the new thing RTR. And so we would need to make this reflexive, but that's easy. That just means that every element ABCD that appear anywhere at all in our relation must be related to itself, right? So since everything appears, so we add everything relate to itself: AA, BB, CC, and DD. Now this whole union will be reflexive. Okay, will it still be transitive? We don't know. It probably still transitive, but that's not the point. The point is we are making reflexive closure. So it is not necessary that the transitivity here follows. This is the important one. When we do the next step, what we care is we made the current relation this property. All right. Okay, I will come back to that later. But next, we have obtained this reflexive closure. Next, we're gonna make it symmetric. So, sorry. So we have this RTR that we just made. What we have to add for it to be symmetric? Well, that's simple. Symmetric means that any pair that appear must have its reverse inside as well. So we just revert everything above, right? So AB give BA, BC give CB, BD give DB. AD give DA. AC give CA. And then the thing that relate to itself don't need to reverse because it will be the same thing, right? So this is the least amount we need to add to make the whole thing symmetric. Now we have obtained the final product. RTRS, as I call it, is a relation that is certainly symmetric because it's the last step we made. Is a symmetric closure of something, so the whole thing is definitely symmetric. But does it still fulfill other requirement to be equivalent relation? That is, does it still transitive and reflexive? For reflexivity, it's easy to see that since everything relates to itself, so this relation is still reflexive as well. So what left to check is, does it transitive? And as you may guess, is not. Well, because I give an answer at the start that is not equivalent relation. But why is not transitive? Well, when we reflect everything here, we have at the start we have BD, for example. When we reflect it, we will have sorry, let me dot it real quick. A, B, C, D. Oh, okay. What we need is, since we have CB as well that we just add, sorry for that, we have CB and originally we have BD, so these two combine. If we want transitivity, we need what? We need CD, right? C to D. It must be related, but there's no element CD in there, so it is not transitive, right? This last product is not transitive by just showing this one pair. So in the end, the whole thing is not equivalent relation. All right, even though each step we made it transitive, then make it reflexive, then make it symmetric, but the property doesn't stick with it through the process. So as I said earlier, the order we do this is important. Why? This is just a thing to think about. When I would say that when you do transitive last, it's probably end up an equivalent relation. All right, but by doing transitive first, we left out on this thing we need, because at the step we made it transitive. This thing doesn't exist yet, so we don't account for this missing piece. But that's this video is taking too long, so just show you one counter example and give thing to think about, that transitive last probably give equivalent relation, but in this order, no, it's not. Okay, that is it for this video. Sorry for rambling too long. Thank you.